Hello and welcome to this presentation of the molecular epidemiology of tuberculous and non-tuberculous mycobacteria in Mubende district of Uganda. First, I'll take you through the overview, the background of Uganda, the socio-anthropological aspects, livestock and human interactions that might affect the infections caused by mycobacteria. Then we would have identified a few knowledge gaps, the objectives of this study, the study approach that we used, the discussions of the findings that we got from the 3 case studies, conclusions that we would have drawn, and a few recommendations, and possibly give you a few pointers on what future research might be, an acknowledgement of those who took part in the study. Uganda is an East African country that lies within those coordinates. It shares borders with 5 other countries. Most of Uganda actually are a plateau which slants from south to the north. Demographically, Uganda is home to 33 million people, most of whom actually live in the rural areas. The population growth rate of Uganda is 3.6, and at that rate the population of Uganda is expected to hit the 130 million mark by the close of the century. Uganda also has one of the youngest populations, with almost 50% of the population under 15 years of age. And the life expectancy of Uganda has actually been fluctuating over the time, and the most recent dip in 1995 was due to HIV/AIDS. But the life expectancy since 2005 has been increasing and is expected to continue increasing until the projection of the end of the century. The highest population density, or the high population density, is around river and lake basins in Uganda. Ethnically, Ugandans can be classified into 2 groups: the Bantu speaking group that occupies the south, the western and central part, and then the non-Bantu speaking that occupy the east and the northern part of Uganda. Uganda is truly a cultural melting pot with over 32 spoken languages. The health delivery system of Uganda is unfortunately stretched beyond its current capacity by non-communicable and communicable diseases. The health delivery system is through allopathic and traditional medicine. Traditional medicine involves bone setting, herbal medicine and spiritual healers. 65% of Ugandans actually seek traditional medicine before allopathic medicine, and to understand this, you need to understand the fabric of the society first. So we did an anthropological study before and found out, especially in pastoral areas, and found out that these pastoralists actually knew that sharing water with animals was a potential risk of getting diseases, but they also believed that wild animals actually were more of a source of disease than domestic animals. Their beliefs were that milk, untreated milk, was actually responsible for the beauty in their wives or their women, and therefore for as long as a pastoralist is looking for a beautiful wife, we obviously know what he's not going to do. They also believed that witchcraft was the cause of disease, and therefore those who had the power to do witchcraft or sorcery also had the power to cure disease, feeding into the synergy of 65% actually seeking traditional medicine before allopathic medicine. Their attitudes were more of complacency, especially about treating water and milk. They knew that these were potentially sources of diseases if untreated, but they were still not willing to treat them, to treat the water. Stigmatization was an integral part of their attitudes towards the disease, especially debilitating diseases and chronic diseases like HIV and AIDS. Most of those who had these diseases were stigmatized and annihilated from society. So then these pastoralists seem to be caught up between a rock and a hard place, because they live in arid areas with limited access to safe water, and therefore they are forced to share water sources with their animals, and this is expected to have an impact on diseases. Diseases, for example, those caused by mycobacteria. Mycobacteria is an aerobic, non-motile, non-spore forming and slightly curved or straight rods that are acid fast with a high GC content in their genome. Broadly, they are categorized into two groups: the tuberculous mycobacteria. These form tuberculous lesions during the disease pathogenesis, but also the non-tuberculous mycobacteria. This actually encompasses all the mycobacteria that is not within the group of Mycobacterium tuberculosis or M. lepari, the one that is responsible for causing leprosy. Anything else that is not in that group actually belongs to the non-tuberculous mycobacteria. Bovine tuberculosis is caused by Mycobacterium bovis. This is a member of the Mycobacterium tuberculosis complex. It's primarily actually a disease of economic importance, costing the UK millions and millions of pounds in the test and slaughter process, but also the curtailment of selling animals outside UK has cost the economy quite a lot of money. It is expected also to cause economic losses to the tourism industry in South Africa, given that most of the buffaloes and the lions now are documented to be infected with M. bovis, one that is actually documented to come from livestock. It is also of public health importance that this M. bovis actually affects human beings and animals, and it's documented to account for 3.1% of all the human global TB cases. And it seems to be fueled by cultural aspects as well, especially the zoonotic aspect. Recently in San Diego, 45% of all the children who came in the clinics and tested for actually had M. bovis, and this was because these were kids who were coming from the Hispanic area and were used to taking cheese made out of unpasteurized milk. So the tastes and preferences to food and cultural norms and beliefs seem to be, compounding the picture of this disease in different parts of the world. Human tuberculosis is actually the big brother to bovine tuberculosis. This is caused by Mycobacterium tuberculosis, which is also in the Mycobacterium tuberculosis complex group. This is only second to HIV and AIDS in terms of killing people on this planet. It's the number one killer it is second to HIV as the number one killer due to a single pathogen. In 2010 alone, close to 9 million people were ill because of tuberculosis, and close to 1.5 million of these actually succumbed to this disease. Now, to put this in context, this is equivalent to 10 super jumbo jets crashing full of people every single day for the whole year. And Uganda, in that light, Uganda ranks 16th among the 22 countries heavily afflicted with TB. And when you put TB together with HIV, the picture becomes much more grim, because TB is the number one killer among HIV patients. Non-tuberculous mycobacteria has also been documented to be on the increase over the last few years. In a meta-analytical study that was done in East Asia, countries like Japan are recording increasing incidence of TB. Taiwan is also recording increasing incidences of non-tuberculous mycobacteria. And if we look at Taiwan specifically, we see that over the years actually the incidence has been increasing, and I'm quite sure the incidence of non-tuberculous mycobacteria of 44 persons for every 100,000 is much higher than the incidence of TB in Taiwan. But this incidence is actually more in individuals with pulmonary infections. There's little that has been documented about Africa, but in a study that was done in 2003 to document opportunistic infections among HIV infected patients, this study showed that actually Mycobacterium avium, or the non-tuberculous mycobacteria, together with Mycobacterium tuberculosis, are an integral part of opportunistic infections that are affecting HIV patients. Now, this non-tuberculous mycobacteria does not only affect human beings, it actually affects animals as well. It causes lesions in pigs, and also causes lesions in poultry, in fowls and turkey. So this dual existence of this disease in human and animals has led to speculations that there could be a zoonotic component to these diseases. But in Uganda, actually, there is very little documentation of molecular characteristics of mycobacteria in tandem with social anthropological aspects that are known to, that are believed to influence the epidemiological picture. And this information is critically needed to inform policy on designing strategic control and preventive measures in these areas. So the objective of this study, the cardinal objective of this study, was to fill in on this information of mycobacteria that is circulating in the environment, in animals and human, but also document the molecular characteristics of these infections and try to identify potential sources and risk factors in Mubende district. In paper 1 that documented the environmental prevalence, we wanted to isolate mycobacteria, speciate it, and find out which are the potential sources for animals and humans in the environment. In paper 2 and paper 3, we isolated mycobacteria from slaughtered pigs and tried to identify risk factors and potential sources for the animals, but also for exposure for the human. In paper 4, we characterized the isolates from animals and human to see if there's a potential, if they have similar characteristics. Then this would point towards a zoonotic situation. But then we also characterize the mycobacteria that is prevalent in human, their drug resistant profiles, distribution in the district, but also the economic factors that might affect the control programs that are prevalent, that are in use today. So the study approach was, if we look at the study site, the districts that we study are in the Uganda cattle corridor. We had 2 comparison sites. The first comparison site was at the northeastern corner of the cattle corridor, that is Karamoja, and then the Nakasongola was for the environmental study. The actual study site that we used was Mubende district. Mubende district is truly an intersection of culture as well, and the more ethnically diverse the area is, the more complex the cultural norms are, and the more diverse you will have mixtures that will affect the pattern of the diseases, especially these that are known to be affected by cultural and behavioral patterns that are linked to the culture. 64% by 2007 was living below the poverty line, and recently documented 18% of HIV prevalence in this area. Most of the people in this area actually live on subsistence agriculture, and they get their livelihood from animals that they keep. The case study that we did in the environment, we systematically sampled from households from Mubende and Nakasongola. Here we sampled water, soil and animal waste, and a questionnaire was administered in the household where we took the samples from. The animal study